So the next parameter is flow rate. So this is going to be a compromise between the speed of analysis and the separation efficiency. So as with reverse phase chromatography, I'm sure you're used to, the optimum column efficiency does vary with the flow rate. So you see the Van Diemter curves that you can generate. So it is important to consider this. Here we have an example of a low molecular weight polystyrene, or very low, like a oligomeric, around the 400 Daltons, and one up at the 2.9 kilodaltons. And you see the effect in changing the flow rate. So the top ones are at 0.2 mil per minute, and the bottom ones are at 1 mil per minute. And for those low molecular weight oligomers, you can see by increasing the speed, you're actually increasing the resolution of your experiment, which is perhaps counterintuitive to those that are working with traditional GPC. Whereas with the larger polymer, there's no degradation of that trace, and you're getting things 5 times faster. So you're increasing the speed, and for the low ones, you're definitely increasing the resolution as well. And as you can see, with the molecular weight data obtained, you're still getting the same transferable data. There's no degradation occurring. When you're going to the really high molecular weight polymers, so here we have going all the way up to 7.5 million. And it should be noted that we specify the APC up to 2 million, so this is really pushing what you would do on an APC. You can see as you increase the flow rate, you start to get a change in that high molecular weight peak. And what you're actually seeing there is slalom chromatography. So that's where you're actually elongating the polymer chain out, so you're not getting true size exclusion mechanism of the coiled polymer. Still no degradation in this case with polystyrene. It's quite strong. So the final method development parameter is going to be around the calibration. So which standards do you want to choose? How many standards do you want to ensure you have a robust column calibration? What type of column calibration do you require, and the frequency of the calibration? So with the calibration, your routine calibration is often overlooked or not optimized in traditional GPC. But it's extremely important because any kind of fluctuations that happen can lead to significant results with your GPC data. So we traditionally look for between 9 and 12 point calibration as a minimum across the expected molecular weight range of your intended analyte. How often do you do it? Is always an interesting question to ask our users. It's never as frequent as maybe they would like due to the time taken to actually calibrate the system. So if you think about traditional GPC runtime, it's between 30 and 60 minutes. And if you have sets of calibrants where you have normally 4 per vial, so this is the optimal situation, that's still 3 vials. So you can be looking at for a few hours to perform a calibration. And so people don't tend to run bracketed calibrations. In fact, they don't tend to run that regular calibrations due to the time constraints. So going back to the polymer that we brought up earlier, so the epoxy polymer, and looking again at the APC column selector tool, it also shows you what calibration kits are suitable. So you have polystyrene, PMMA. So depending on what solvent you choose and depending on what bank of columns you have, it'll suggest both the chemistry and also which type of kit which is optimized for your column bank. So here we have selected a polystyrene calibration, the most common type of standard for THF-based polymer chromatography. And we've actually shown side by side performing bracketed calibrations on an APC compared to traditional GPC column set. And you see it's taken us for 4 samples, including replicates, with a bracketed calibrations to really push the precision up and also to spot any kind of things that have gone wrong with your system earlier. That has taken 90 minutes with the APC, and this exactly the same process on traditional GPC has taken a full day. So as you start to scale this, you can see just how much more throughput you can do, but also importantly, how much more confidence you can have in your data because of the increased calibration that you brought to bear. So I said that we have matched the molecular weight resolution range of the APC column chemistries to kits, pre-made kits that you can buy, which are vials with 4 standards in each vial, and it come in a set of 3 to give you a 12-point calibration. So the final step is going to be the data processing and the reporting. All this is going to be conducted within software, so within the Empower chromatography data system. So here we see some samples that we discussed in the previous slides, and here we're using the quick start interface of the Empower GPC console, as it's the simplest to visualize and interact with. When you do your calibration, and predominantly this is usually with now standards, although other calibration modes are available, but I'll be talking today about the now standards as being by far and away the most common. You're going to fit a curve to those calibration points, and it's important to note here the importance of having the calibrants cover your molecular weight range, because outside of there the software is going to extrapolate, and this can lead to precision errors if your polymer sits outside of the calibration range. So this will lead to having your set points for your maximum and your minimum retention times, and therefore molecular weights. You can do various data processing. There's an awful lot of data processing capabilities within Empower. This particular case is just showing how you can drop a perpendicular across your distribution if you want to maybe separate out the additives from the polymer, or maybe the oligomers from your polymer. You can readily do that within Empower to make sure that you're getting the distribution of your analytes of interest, and you can even set up both so that you can do these simultaneously, and you have both reported data in one run from your polymer and your additives, for example, or your oligomers, maybe if you're doing something like REACH. So when you look at the overlays of the data, and this is something which the APC excels at, as the reproducibility of the data. You can see we've highlighted a lot of replicates here, and you can run a report which will run all the statistics over the reproducibility, again to give you confidence that your method is correct, that you aren't seeing some deviations either due to some kind of unexpected system fault or more likely non-optimal method. So now we've completed our look at the method development approach to the Acuity APC, the system, columns and standards. So to summarize the workflow of approaching method development with the APC, it's the same as GPC. You have to consider a number of factors to ensure you have a very robust and appropriate test. So first and foremost, the goal of the analysis, then what are the properties of your polymer, the chemistry, the molecular weight, correcting the most suitable solvent, the most mobile phase. Which detectors do you need to ensure that you're getting the information that you require out of your experiment? Where the APC takes it to the next level is the ability to screen multiple solvents to ensure that you have the best separation, best mobile phase to do that separation. And then within that solvent itself, how to optimize that mobile phase through the use of additives or modifiers. You can both screen and optimize on the APC very easily, which is something that's very difficult to do on traditional GPC, both due to the time constraints, but mainly due to the polymeric columns themselves. You need to ensure that you select the correct calibration standards to the column bank pore size, which again is facilitated both in terms of the APC column selector, but also the calibration kits we have available. And then you can choose and optimize your processing for your analysis to your particular requirements, and ensure that you are getting the data consistency and reporting that you need. So thank you for your attention. If you have any further questions on method development for SEC or for the Acuity APC, please contact us here at Waters.